Hello friends, I am Dr. Lokesh Desrai and in this video we are going to discuss how to compute mean in SPSS. What is the purpose of means analysis? Means analysis is used to compare the average values of a dependent variable across different groups of an independent variable. Examples are: does distance from home differ across occupations? Do males and females differ in satisfaction? Do different income groups differ in purchase intention? Once you are calculating the mean analysis with the SPSS also computes following results along with the mean analysis: ANOVA, R square value, eta and eta square. So what are the purposes of these statistics? Purpose of ANOVA: to test whether mean differences between three or more groups are statistically significant, to check if the independent variable has a real effect on the dependent variable, to compare between groups variation and versus within group variation, to decide whether to reject the null hypothesis, it means all groups means are significantly equal. Purpose of R square: R square shows how much variance in the dependent variable is explained by the independent variables, indicates model explanatory power. Its values ranges from 0 to 1. Higher R square indicates better explanatory strength. Eta, it measures the strength of association between variables. Similar to correlation, it ranges from 0 to 1. Eta square, it measures effect sizes ANOVA. It shows proportion of variance explained by group differences. If its value less than 0.1, it indicates the small effect. If its value 0.01 to 0.06, it indicates the medium effect. And if the value beyond 0.14, it indicates large effect. So now we open SPSS datasheet and compute mean analysis. This is a retail.sab file, and to compute the mean analysis, go to analyze, compare means. Now first we select the continuous or numerical variable and transfer it to the dependent list. So we select distance from home and select here. Now in the independent list we have select the independent variable which is having different categories. So we select occupation and transfer here. Go to the option. By default, the software calculate mean, number of cases and standard deviation. So you can select desired statistics and transfer here. We also select ANOVA table and ETA and test for linearity. Continue and press OK. Now the SPSS output viewer windows gives these following results. The first table indicates the mean of each occupational category with respect to distance from the home. Now this table indicates that the highest mean distance from home belongs to the housewife category, followed by private employee, students, business class, and government employees. The second table indicates the ANOVA result. Now this ANOVA results indicates the F statistics value for a ANOVA between the groups difference, that is 0.793, it's a p-value. Now the result of linearity among the different occupational categories, it is the p-value is 0.351, and the result of deviation from linearity, it is p-value is 0.847. Now the next table indicates the measures of association. The R value 0.087, R squared is 0.008, eta is 0.12, and eta square is 0.014. So what does it mean? We go to the PPT once again. Now, the first we discuss the result of linearity. So this test indicates whether there is a straight line trend between independent and dependent variable. Now this p-value is 0.351, more than 0.05 at 5% level of significance. So we can interpret that there is no significant linear trend between occupation and distance from home. What does it mean? It means that if we increase the categories of occupation, then the dependent variable distance from home does not indicate any linear trend. So it means it is non-significant. Now second is deviation from linearity. If there is no linear trend, then there may be a possibility that other linear effects or other non-linear effects will be there, such like curved or irregular. So this test indicates whether the relationship is non-linear. That means it indicates whether curved or irregular relationship between the independent variable and the dependent variable. Now again its p-value is greater than 0.05, that is 0.847, then we can interpret that there is no significant nonlinear pattern either. So the relationship is neither linear nor curved. Basically, no systematic pattern exists in this relationship between the distance from home and a different occupational categories. Now, the result of ANOVA indicates the F statistics, degrees of freedom 4 and 115, and its value is 0.422, and p value comes 0.793 at 5% level of significance. So we can interpret that there is no significant difference in the mean distance from home across different occupation categories. Now again our result of ANOVA is also non-significant in this case. Now R square value comes 0.008. If we multiply it with 100, we can explain that occupation explains only 0.8% of the variance in distance from home. So it's extremely low explanatory power. Eta is 0.120. It's a very weak association between occupation and a distance from home. Eta square is 0.014. It indicates 1.4% variance explained. It means a very small effect size exists between this relationship. So overall, we can interpret that the occupation does not significantly influence distance from home, and the relationship is very weak with a negligible practical impact. So friends, in this way, you can compute the mean statistics for a one dependent variable for a different categories of an independent variable. Once you calculating the mean, then the SPSS also computes, also gives you the result of three major statistics, that is ANOVA, R square, eta and eta square, and the linearity and the deviation from linearity results. I hope you understood this mean analysis. So thank you for watching this video and kindly subscribe the channel for next video in this series. Thank you so much.